Let's move on to some examples. A study collected high school standardized test scores, X, and college calculus grades, Y, for a sample of 10 students and calculated S of XX to be 2474, S of YY to be 2056, and S of XY to be 1894. Is there sufficient evidence to conclude that high school standardized test scores and college grades are linearly correlated? So essentially, we want to know whatever this test is the null hypothesis true? That's rho is 0, there's no correlation, or the alternative, that rho is not 0. So first, we have to compute our estimate of rho. We have to compute R. R is going to be S of xy over the square root of S of xx, S of yy. That's going to be 1894, as given in the problem, over the square root of 2474 times 2056. And R ends up being 0.8398. Now already I'm thinking that's probably not going to be 0 when I do my test, but we want to actually run the t-test to figure out if that's the case. So my t-statistic is r times the square root of n minus 2 over square root of 1 minus r squared. That's going to equal r, which was 0.8398 times square root of n minus 2. There were 10 students, so that's going to be 8. I'm going to divide that by the square root of 1 minus 0.8398 squared. And if I work that out, that's going to be 4.375 with the degrees of freedom of 8. Now my rejection region is t bigger than t.025, and we would have to calculate t.025. So I'm going to go to my t distribution chart, and I'm going to go to a degrees of freedom of 8. For the column of 0.025, I get 2.306. So t has to be bigger than 2.306. So that means we can reject the null hypothesis. Okay, so x and y are linearly correlated. But what does r tell us? R squared actually tell us. So since r squared in this case is 0.7053, what that's saying is about 70% of the variation in college calculus grades can be explained by the high school standardized test scores. So that gives us an understanding of what r squared is telling us. There's going to be variation in college calculus grades, but what's causing that variation? Well, we're saying that 70% of the variation is explained from the high school standardized test scores. So I doubt this is something like SATs or ACTs. Maybe this is something like the AP Calculus exam. Okay, let's move on to an example that we've visited many times, and that is the data on global temperature change versus CO2 levels from the NASA climate website. We have our summary data that we've used before. Again, we want to know, is there sufficient evidence to conclude that the global temperature change and CO2 levels are linearly correlated? Okay, so H0 is rho equals 0. Our alternative is that rho is not 0, that there is a correlation. Okay, again, these are going to be very similar. R is going to be S sub xy over the square root of S sub xx times S sub yy. And I'll plug those in. So we have 486.982 divided by the square root of 46,332.885 times 5.618. So R in this case is 0.954. Okay, so that's a very high correlation. Okay, what is our t statistic though? We want to make sure that it's not 0. So we're going to take r times square root of n minus 2 over the square root of 1 minus r squared. That's going to be 0.954 times the square root of 59. We're going to divide that by the square root of 1 minus 0.954 squared. And that actually gives us a t statistic of 24.58 on 59 degrees of freedom. So that's a really large test statistic. I think it's going to be significant. Our rejection region, of course, for degrees of freedom equals 60. We actually, or 59, but we actually, in a previous video, rounded that to 60, and we saw that the rejection region was t was bigger than just 2. Okay, so clearly we need to reject the null hypothesis, and we see that the temperature change, global temperature change, and CO2 levels are correlated. Okay, so global temp and CO2 levels are correlated. Okay, well, what else can we say? Well, r squared in this case is 0.911. Okay, that says about 91.1% of the variation in global temperature can be explained by the change in CO2 levels. So that's important. We're saying 91.1% of the variation. In this case, we saw, remember, that the variation was actually an increase, right, in global temperature. It increased from down here to up here, depending on the CO2 levels. And so 91.1% of the increase in global temperature can be explained by the change in CO2 levels in the atmosphere. I'm including a link to another video that I'd like you to watch about correlation versus causation. And I want you to think about some of the examples that are in that video as well.